We have a position versus time graph and with sections A, B, C, D, E, F, G, H, and I. So we're going to be using these sections as references for our questions. So the first one is, which section has the greatest magnitude of displacement? So remember, displacement is just the final position minus the initial position. So if we're looking at each section, we're looking to see which one has the greatest change in this Y scale position. So looking at this, I can see that here I have E from -6 to -6 has a -12 displacement, but also here from 6 to -6, 6 minus -6 is a positive 12 meter displacement. So it's going to turn out E has a displacement of -12, and G has a displacement of positive 12, because my final position was 6 meters for this section, minus -6 is where I started, so that's positive 12 meters. But since it's the magnitude of the displacement, I'm just looking to see how far I changed position, and both of them changed by 12 meters. Okay, now for section C, the displacement, if I'm looking at the final position, I'm at positive 6. And then the initial position is -2, so minus -2. And that'll be 8 meters. The distance from 10 to 20 seconds. We're looking at the second half of the graph. Well, here's 10 seconds. Here's 20. So I'm trying to find the total distance. So this first distance, I am moving section E, and then it'll be section F, and then G, H, and I. Now in section E, I'm moving 12 meters because I'm going from 6 meters to -6 meters. Section F, I'm not moving. Section G, again, I know already from this it's 12 meters because I'm going from -6 meters to positive 6 meters. In H, we're not moving. And then from H, I'm going from 6 meters to, and then I'm ending at 0. So that's going to be 6 meters. So I just have to add all of these up. So 12 plus 12 is 24, plus 6 is 30 meters total in distance. Now for the displacement, that's just the final position minus the initial. The final position is 0. So I ended on 0 meters minus my initial position at 10 seconds is positive 6. So my displacement during that time was only 6 meters to the left. Okay. Which section represents an object at rest? Well, we've got a whole bunch of these. So this is going to be when the slope equals 0. Because the slope, remember, is velocity, right? So if we have the slope of 0, then that means my object is not moving, it's at rest. So that's going to be B, D, F, and H. All right, so that's all of our horizontal lines. For F, we want to look at what sections are moving in the positive direction. So if they're moving in the positive direction, this means that the velocity must be a positive number. So that means we need to be looking for a positive slope. So if we take a look here, positive slope means it's going up from left to right. That's going to be A, C. Now E, notice, is going down from left to right, but then G is going up. And then I is going down. For G, we're looking at the object's motion during section D, and we're trying to describe motion and position from the origin. So let's take a look at D here. And notice D is a horizontal line. So what that tells me about the motion is that the object's at rest. Now we also want to talk about the position of section D, and the position is at 6 meters, so that means it's in the positive direction from the origin. So here we have the object is at rest, and then in a positive position. So if we were going left and right, we would say it's at rest to the right of the origin. Okay, which section's moving fast in the negative direction? Well, we only have 2 negative directions. We have E and we have I. If we want to know which one's moving the fastest, we have to take a look at the velocity during that time. So for E, notice my change of position was 12. We calculated that a bunch. So for E, the velocity of E, we have negative 12 meters during, that 12 meters happens during 3 seconds. It's from 10 to 13. And so we're going negative 4 meters per second. Now the velocity of I, let's take a look at the change in position. So we're going from 6 to 0, so that's negative 6 meters. And we're doing that during also 3 seconds, from 17 to 20. So this equals negative 2 meters per second. For I, we're looking at what 2 sections have the same non-zero positive velocity, and we want to know what that velocity is. Okay, so that means we need to look at the velocities for all the positive slopes, and that's going to be A, C, and G that we identified already. So for A, we're going up from negative 6 to 2, that's up 4 meters. So the velocity of A is 4 meters in 2 seconds. Notice that's only in 2 seconds from 0 to 2. So that's 2 meters per second. For the velocity of C, let's take a look. For C, we're going up up 2, 4, 6, 8. So we're going up 8 and then right 2. Now notice we're only going up 4 boxes, but each box is 2 meters. So up 8 meters in 2 seconds. So 8 meters over 2 seconds is 4 meters per second. And then the velocity of G, we're going up 1, 2, 4, 6, 8, 10, 12 in 2 seconds. So this equals 12 meters in 2 seconds. And that is 6 meters per second. So I didn't get any of the velocities the same unless I did something wrong here. 8 over 2 is 4. 12. 2, 4, 6, 8, 10, 12 over 2. So I guess it's a trick question, right? 1, 2, 3. So this is none. Trick question. Good practice, though. All right. And then which 2 sections have the same non-zero negative velocity, and what is the velocity? So for the sections that are moving in the negative direction, there were only 2, right? We already found that. Same non-zero, and what is the velocity? So we only had 2, and I know that VI is not equal, VE is not equal to VI. So we already calculated that. And then calculate the section, the velocity in section B. That's a simple one. In section B, right, there is no change in position. So the velocity in section B has to be 0 because it's going to be 0 meters over 2 seconds. So that's 0 meters per second. But anytime you have a horizontal line, the velocity is going to be 0.